Hi everyone, we're going to start looking at Pythagoras theorem in today's lesson. So let's jump onto my whiteboard and figure this out together. So Pythagoras theorem is a theorem based on right angle triangles. So we've got a right angle triangle right in front of us here. Now what the theorem states is that there's a relationship between these three lengths. And in the past, we have looked at right angle triangles and we've said that there are certain names we use for certain sides, right? So opposite of the right angle, which is this side here, opposite of the right angle is called the hypotenuse. I'm just write hype here. We've got this as adjacent to this angle. Okay, if that's an angle that we don't know, if that's an angle that we're focusing on, below that is an adjacent angle. And opposite to this angle is called the opposite. Right, so we've got hypotenuse, opposite, adjacent. Now, for today's lesson on Pythagoras theorem, we don't need to know all of those, but we do need to know that opposite of the right angle in a right angle triangle, opposite side of the right angle is always the longest length. Okay, out of the three sides, that's always the longest length. So we've got to know that, okay, for today's main part of our lesson. Okay, so let's have a think about this. So what does the actual statement say, the theorem? It says that the area, it talks about the area of this square and the area of this square here, and it links it to the area of, if I can do that, not very well there, if I can do this to this square, might not look like a perfect square here though. Okay, here we are, something like that. Okay, so it kind of states that there's a link between them. Now we know that the area of this square here is easy to work out. It's a 4 by 4 square, and so this is going to be 4 times 4, which is going to be 16 square centimeters. And the area of this square must be a 3 by 3, which is going to be 9 square centimeters. And so we've got 16 and 9. If I told you that there's a link between these two squares and the area of the third square, which I've drawn out there, can you see what the link might be? The area of this square is going to be 25 square centimeters. And so the theorem, Pythagoras theorem, states that if we call this A, if we call this length B and this length C, then we can say that A squared, right, that's 4 centimeters here, it's 4 centimeters. A squared, which is 16 square centimeters, add B squared, which is 3 by 3, which is 9 square centimeters, is equal to, this is C squared, which is 5 times 5, which is 25 square centimeters. So Pythagoras theorem just states that A squared plus B squared equals to C squared. And that helps us then work out the lengths of certain sides of a right angle triangle if we're given two sides. So let's go for a question that we can understand. Let's say we've got, let me get rid of all of this. Let's say we've got a right angle triangle. Okay, we're going to keep the Pythagoras theorem here. We've got a right angle triangle like this. Okay, we're not going to, we're going to say actually this is not drawn to scale. Okay, so we've got 6 centimeters here and 8 centimeters here, and we'll call that X. So A squared plus B squared equals C squared is something we can use, right? We can say that 6 squared plus 8 squared is going to give us the area of this, right? Of this square. 6 squared is 36. 8 squared is 64. 36 add 64 is 100. So it says A squared plus B squared equals C squared. That must mean that, or in this case, X, right? It's not C, it's X squared. This is the length X. And so that must mean that this whole length X squared must be 100. This whole length X times X, which gives us the area of this square, must be 100. And therefore, X must be square root of 100, which is equal to 10. So this length here, X, is going to be 10 centimeters, considering that this is 6 and this is 8. So in this example, we've got a right angle triangle. We're given the two shorter sides. How do I know that they're shorter sides? Well, we've talked about the fact that opposite of the right angle is always the longer side. So C always relates to the longer side. Okay, so it's saying the two shorter sides squared is equal to the longer side. Two shorter sides squared, the sum, sorry, of the two shorter sides squared is equal to the longer side squared. That's where Pythagoras theorem comes in. So we've got an example here, which you can see. We'll go through another example so that we can see that it doesn't change. We're going to go through another example where we have another right angle triangle, because Pythagoras only works with right angle triangles. Now this right angle triangle might not look very much like a right angle triangle, but you can take this symbol here to tell you that it is. Okay, let me make that a bit straighter. There we are. Okay, right, now we're given that this is 15 centimeters and this is 8 centimeters, and we're asked to work out what x is. So we're going to use the same approach, right? Maybe you want to try it out, pause the video and see if you can do this yourself. And then you can see if we've got it right by following my instructions after that. So how do I work out the longer side? Well, how do I know it's the longer side? Well, opposite of the right angle, that's the right angle here. Opposite of the right angle is this length, x, and that must be the longer side. And that must mean that these two are the shorter sides. So we can say 8 squared plus 15 squared is equal to x squared. 8 squared is 64. 15 squared is going to be 225. And so 64 add 225 because x squared. Now, most Pythagoras questions, you're going to be allowed to use calculator, because sometimes your square root part of the question might give you a whole number answer, and sometimes you won't get a whole number answers. Most of the times you probably won't. Okay, and so here we're going to add 64 to 225, or 225 add 4 is going to be 229. 229 add the 60 now, it's going to be 289. So x squared equals 289. Now, you're probably not going to know what square root of 289 is, because we're going to have to work out x is equal to 289 square root. And if we want to, if we don't know, we can use calculator to work that out, because it's perfectly reasonable for that. And you can find out that square root of 289 is equal to 17. So x is equal to 17 centimeters. So that's how we work out questions where we're asked to work out the longer side of a right angle triangle when we're given the two short sides. Now, we also have other questions where we're asked to work out the actual shorter sides, or one of the shorter sides, given the longer side. So, for example, we might have a question like this. We've got a right angle triangle, and we're told that this length is 12 centimeters. This length is 12 centimeters, and we might be given one of the other lengths. So, for example, we might be told that this is 5 centimeters. Right? Seems like a longer side, so maybe the other one, yeah, is 5 centimeters. Okay, so we've got 12 centimeters, 5 centimeters, and x centimeters. We're asked to work out what x is equal to. So we know Pythagoras theorem says that a squared plus b squared is equal to c squared. In this case, a and b are the smaller sides and c is the longer side, but we don't know what one of the shorter sides is equal to. So I'm going to write that down again. A is 5 centimeters, 5 centimeters, or 5 squared, add b's x, so I'm just write x squared, is equal to 12 squared. And so using our knowledge of algebra and how we manipulate equations, we can say actually that if I want to work this out, I can take away the 5 squared on both sides. And so I'm left with x squared is equal to 12 squared take away 5 squared. Take away 5 squared, there we are. So I've got x squared equals 12 squared plus 5, take away 5 squared. Right, let's work out what x squared is. X squared is equal to 12 squared is 144. 5 squared is 25. And so if I took that away, x squared is equal to 144 take away 20 is 124, take away 5 is going to be 119. X squared is 119, and therefore x is going to be square root of 119. And so we can work that out, right? Square root of 119, what's that equal to? Looking at the calculator, it says 10.9087, and it goes on. 10.9087, and it goes on. Now, most questions will require to use 1 or 2 decimal places. So I'm going to write this down up to 2 decimal places. 10.91 centimeters. X is equal to 10.91. How can I check if I've done the right thing? Well, one thing is that it can't be, this length cannot be the longest length. This is 12. So firstly, we have to know that it's going to be under 12, and 10.91 is under 12. So it makes sense, right? If I had an answer where I've got one of the 2 small sides and I'm trying to work out the small sides, and I get an answer that's larger than the longest length, how do I know it's the longest again? It's opposite of the right angle. Then I know I've done something wrong. Okay, so before you go on to the questions for the lesson, just a quick recap. We've got a right angle triangle. Pythagoras theorem helps us to work out a length of any right angle triangle as long as we have 2 sides. Now, if we're given the 2 shorter sides and we're asked to work out what C is, then what we do is we square the 2 shorter sides and add them together. That gives us the square of the longer side. But we don't want to work out the square of the longer side. We want to work out the longer side. And so in order for us to work out what C is rather than C squared, we have to square root the answer to A squared plus B squared. Whereas when we've got a right angle triangle and we're asked to work out one of the shorter sides, it doesn't matter which one. Let's say A and C is given, and we're trying to work out what B is, right? That means we're going to do C squared take away A squared is equal to what B squared is, right? This is B. And so to work out what B is, we're going to do the square root of C squared take away A squared. Now A just represents the smaller length. It could be A or B, doesn't matter. The difference between the 2 questions is going to be what? Can you see what the difference is? One is subtracting, and whilst the other is adding, right? We're adding the 2 shorter lengths to work out the longest length, or the square of the longest length. And for the second type of question, we're subtracting the square of the shorter length from the square of the longest length to work out the square of the missing shorter length, right? It could be the shortest length, or it could be one of the shorter length, but it will never be the longest length. C is always the longest length. So bear that in mind before you jump onto the questions. You have to kind of check yourself. Am I being asked to work out the longest length? Am I being asked to work out the shorter length? And then decide whether to add or subtract the squares. Don't forget, the longest length is always opposite of this right angle triangle. Have a go at those questions, and I'll see you in our next lesson. Bye.